Welcome to this series of interviews about transitioning to IP. I'll be talking to leading industry experts about the challenges they've overcome, the decisions they've made, and their long-term thinking. I'll be talking to Geir Borderland, who's head of technology portfolio for the Norwegian Broadcasting Corporation, and Geir is building a greenfield site. I'll be talking to Paul Markham, Director of Media Infrastructure for Software at Discovery. And I'll be talking to Dave Schwarz, Managing Engineer for Diversified. And Dave has more IP infrastructures under his belt than any of us would care to imagine. As we move to IP, we need to start thinking more about how we make the system work for ourselves. I mean, it's one thing building an IP system and getting it to distribute video and audio, but it's quite another in making it work efficiently. That's in terms of being flexible and being dynamic and being able to give us all the advantages that we want from IP. We use monitoring obviously a lot in television for video and audio, but as we move to IP, we need to know a bit more about what's going on in the transport stream. So we need to know where the packets are and what they're doing. And monitoring in IP allows us to do this, but logging gives us another dimension, and we'll be talking a little bit more about logging later on. We also have to develop our agile mindsets as we move more to software. Agile thinking and agile methodologies start to dominate, and we really need to sort of think about how we spin up servers, how we spin down servers, how we build software-based networks, and how we really develop those systems to give us all the advantages of IP we want. And the age-old question, to compress or not to compress? Should we compress? I was speaking to Dave, and in a few minutes you'll hear what he has to say about that, and he has some very interesting views. And cloud computing, I mean, there's a lot more to cloud computing than just putting stuff into big data storage in the cloud or using the process power. You know, we have ingress and egress and the charges associated with all that. So I start by talking to Geir about his cloud requirements and see what he thinks about it all. Do you see cloud as the way forward?
Oh yeah, most definitely. And I got a question a couple of days ago if I was thinking that cloud was overrated or underrated. And I think I went for the bold solution that it was underrated. I still think we have a lot of things that we can do with the cloud. I think it's a lot of power in the big vendors out there. But it takes time also building the new software and utilize all the new possibilities. And you need clever people that know the possibilities into this and also are able to build user-friendly solutions for the users. So, what we really like is kind of tailor-making the tools that are closest to the journalist. And I see a lot of other companies also in broadcasting that has done the same. They've built a lot of the ground solutions with the archives and the infrastructure there and the metadata structures themselves, and they built a lot of the software on top. Still, I think it's a lot of possibilities for vendors out there to build the production equipment, a lot of the workhorses in radio and television editing, and other stuff also into this. So I still think it's going to be a great joint venture in between what we are building ourselves and what the vendors can provide. And we're definitely looking for vendors here that give us great tools.
Okay.
Yeah.
And do you ever see a time when the facility will be working entirely from the cloud, or will you always have your own data center?
That's an interesting question, because one of the things I'm really worried about or looking for solutions for is how would we treat the big environments for editing up in the cloud? Because today our production infrastructure for editing is about 24 petabytes. Everything running on a huge Isilon system, which is regionalized both with a big installation in Oslo and also out with 12 different sites around Norway. So could we run this from a cloud environment? Well, we probably can if we could get the back end of the editing also to work up there. And I've already seen several solutions that is starting to utilize the cloud for big global systems for this. I can see systems from Sony, for example. Now they built systems from Reuters, and we've seen Wizard with solution and also others with a lot of solutions using the cloud, but I haven't really seen any big broadcaster moving the whole infrastructure for editing up in the cloud yet. But I heard something that CBS is looking to move stuff up to Amazon a couple of days ago, or it was yesterday. But I still think we need to see how we should do this, get this to work in the scale we're thinking about. But I think the best way will be to kind of pilot testing a smaller environment that's not so crucial for production. Probably not start this in the news environment. I have 10 years background as head of technology for news. I know news is not exactly, they don't like beta testing if they don't have to. So use some other departments, children's or sports. Sports are very good for beta testing. So then we probably will figure out how we should do this in the best way. Then eventually, I think we probably will see things rolling in the direction of the cloud.
Okay. And what do you think is the blocker at the moment to stop edit systems going into the cloud? Is this purely a technological issue or something else?
I think storage definitely is one of the things you have to figure out. I call storage the magnet. If you place a magnet in the cloud, everything will start rolling the same way. Transcoding would follow right after it. The playout will follow very, very shortly. So I think it comes down really to where you place the storage.
But you can have as much storage as you like in the cloud, can't you?
Yeah, but it has to be also, of course, in the price-wise, that it could be in a way so we, in fact, we're doing it. I guess we've been talking way too little about the economics about the cloud solutions here. I still have my experts in this say it could be definitely a lot more expensive to place these amounts up in the cloud, but I think it comes also down to making the good business cases and making the good solutions that makes it viable also to place stuff in the cloud. And I think we will be there.
And I think that's something we have to consider more, isn't it? Is the business case, because it's quite easy to look at things purely from the technology case and the spreadsheet and how much it costs to store objects in the cloud and assets in the cloud. But then when you start to consider, well, if we stored it in our own data center, we'd have to have another building, which has its own costs. So are you seeing more and more business case decisions being made?
I wouldn't say I've seen more and more, but I definitely think we are working much more on the business cases now around this. So I think we are in fact working on these solutions right now to see and figure out which solution would be the most viable. But this needs more work until we really start rolling the big balls from our own data centers and over to the cloud solutions.
Well, from speaking to Geir there, it seems that cloud is definitely the way to go. But there were some caveats. He said we have to be a little bit careful about our costs, and these need deep analysis, and we have to really sit down and work out what's going on. But I would say that the caveat there also is that we have to truly cost our data centers. I mean, if you are going to build a hardware data center, then it's not just about the equipment. It's about the building. It's about the resilience. It's about the power management. It's about the air conditioning management. It's about all the people we need to run it. And when you factor all those costs in, I can see why cloud suddenly looks very appealing. IP gives us the opportunity to look more at software to gain the flexibility and scalability we really need. And one important aspect of all of this is monitoring and logging. IP networks, as we want them to be, is more than just the network. I should say IP infrastructures are more than just the network, because we have to consider the VMs, the servers, how we spin servers up and down, how we allocate VMs, I mean the software running on them, where is the software running on them, where's the data? And all of this comes under the heading of monitoring and logging. So we're looking at more than just the actual network now, we're looking at entire infrastructure monitoring. I had the opportunity to speak to Paul about this, and he has some very interesting views on logging and monitoring and how we work this with make this work with our agile mindsets. In traditional television, we have scopes, vector scopes, waveform monitors and such like. Logging isn't something we've really ever done. But with the networks we're talking about, with the infrastructures we're talking about, I would have thought logging is really important, and monitoring is really important to many different levels.
Absolutely. And I think one of the buzzwords you do hear in the kind of DevOps startup industry is observability, which I guess is their word for knowing what's going on in every part of your system. And absolutely for our industry, wow, we need so much observability. And yes, I think if you're talking about spinning up virtual instances for a sporting event that you're then going to spin down afterwards, well, you need to be gathering those logs in a central place. You don't want to be going and after the event's finished, looking at logs on 30 separate instances, because first of all, that costs you money if you want to leave them running, and secondly, it's painstaking, and what are you going to do? So you need to use those systems like there's commercial ones like Splunk or Sumo Logic, or there's Logstash, what they call it, Elk Stack, with Elasticsearch these days. So they're all very, very useful tools for bringing logs together in a certain place, making them searchable, and certainly, particularly if you're using ephemeral instances for any purpose, that's an essential part of the system. In terms of monitoring, I think it's another change in mindset, because we're used to monitoring CPU or RAM usage, or whether hosts are up or not, and all of those sorts of things, which in a virtualized software defined world, it's not useful, but I guess it's a lot less useful, and you need to start thinking about monitoring the different layers of your service offering, in terms of if you've got a stack of different components that rely on each other, and you've got maybe you might have something like a container orchestration platform like Kubernetes, and you might be running a whole bunch of containers, and so you need to be monitoring the different layers of that. You need to be monitoring, okay, is my container orchestration platform, does that have enough resources, and are all my containers working, and is everything there? And you're no longer thinking about bits of hardware, you're thinking about all of those bits of software and that hierarchy of dependencies that all of those things are relying on. And you have to be logging and monitoring and observing all the way up and down that stack, so that if there is a problem at one level, you can quickly narrow down where that problem is. And there's a lot of, I've certainly heard talk of this sort of idea of bottom up and top down monitoring. So the bottom up is clearly, if you're running on-prem hardware, and it's say you've got a VMware farm or something like that, you need to be monitoring that the servers are all running, that the disks are all functional, the network's all there, and all those sorts of things, and sending out alerts in the traditional way if anything fails on that level. And that's kind of, I guess, what you could call the bottom up monitoring. But then I think you've got this really important top down monitoring, which is this service that's supposed to be there working? So on the very simple level, that could be a TV channel. Is the channel getting to all the places that it should be?
Yeah.
I guess you've got other things in that stack, like services that you would offer to internal users to perform functions like, maybe web applications or something like that. And are those working? And how do you confirm that those are working? How do you monitor that those are successful, that maybe web servers are running, that maybe middleware components are running?
So there's almost an implication there that when the software is written, all the hooks necessary for all these extra bits of code, these third-party pieces of code, have to exist within the code as it's been written. Is that right?
Well, I think you've got to be careful there, because this is back to that agile mindset of don't worry about it before you've written anything. I think it's something that you do need to factor into your non-functional requirements, if you like, when you're doing that development. We need to monitor this. We need to know that this is working. And this is a common pitfall, is to, especially, when you're a software developer or software architect, it's very tempting to think, oh I've thought of this great application, it's just going to work all the time. I think it's very, or whatever you're building as a technology architect, you tend to be happy path in terms of how well it's going to work, and it is difficult to look at that critically and say, okay, so what can go wrong, what might go wrong, what do we need to be watching, and so when you're thinking about that top-down mindset, it's a good way of thinking about what's important, because there's so much to monitor here. There's so much data that you could be looking at, and you've got to make sense of it, and you've got to somehow work out what's really going to affect your service. Because if you've built lots of layers of resilience in, it may be that you can lose half your instances and your service is still fine. That doesn't mean you don't need to do anything, but your service is still working. So I guess you've got a whole layer of intelligence that you have to build on that monitoring, don't you? To say, here's what we need to know, and here's when things are going to get really bad, and here's when channels are threatened or events are threatened, and equally, if there is no impact, and this is often one of the challenges I think we have, because we do build in so much resilience in our platforms. If there's no immediate impact, how do you get the monitoring to tell you that you need to replace that power supply, you need to replace that drive, you need to do whatever it is? Because if you just leave those things, eventually, obviously, you're going to get to a point where there is an impact, and that might be a pretty serious impact because you built all that resilience for a reason. So I think these definitely are challenges that are quite special to our industry. I wouldn't say they're unique, but a lot of web startups kind of work on the basis that even Facebook is kind of a bit like, oh well, if we break it, we'll fix it, and we can't think like that. We have to get there before anything's broken. Sure. And maybe that makes things a big challenge, doesn't it?
So as we can see from listening to Paul there, that monitoring is more than just about looking at the data in a network. And we have to think about the VMs, we have to think about the servers, we have to think about the network switches. It's entirely possible that an app could have failed on one VM, but in a resilient system, the same app has taken over on another VM, so that it's running, and from a user point of view, we don't know if something's actually failed. And I suppose the key there, and the challenges we have there, is knowing when to go in and fix a system. If we can see that something is broken, should we go in and fix it, or should we just leave it? It might be that we just leave it till the show's finished, because we're going to switch everything off anyway, and then power it all or spin it all back up the next day for the next show. Very interesting thoughts. So when I spoke to Dave, we discussed some of the detail of how infrastructures work, and what I wanted to get from Dave was some detail about latency and compression, and he certainly had some very interesting views. So on the subject of compression, we often talk about uncompressed signals within a production environment and why we would use those. Do you ever see a need or an application to use compressed signals?
We already are. Now, every one of us who builds a system is already using compression. It's just how we're using it. So the question is, when does compression move into what we consider the uncompressed environment? Right now, if you put something, if you ingest something into your edit system or your slow-mo replay system, you're compressing it. If you take a feed from bonded cellular or take a feed from a service provider, it may be handed off to you in an uncompressed format, but it was compressed in the transport. So you're already using compression. Some of the newer compressed formats, I think they're going to end up hitting. Well, we already had one vision mixer vendor put compression in, and for Tico, Grass Valley did. They pushed the boundaries, but you're seeing others starting to do that too. Not with that, but with JPEG XS is what seems to be on the horizon. I think you're going to be seeing a lot of compression in a lot of distribution and places where it's fully optimal. First of all, the new compression is so good and so close to lossless that you can make an argument that if you're not doing green screen work, maybe your weather camera for your weather set is uncompressed into your vision mixer so that you can minimize artifacts on the chroma key. But other than that, if we could process all this in a compressed mode, we would save a fortune on bandwidth on the switches. For years it was said that we couldn't do master control in a compressed format. Now, master controls are done in compressed formats all the time. So it's coming. It's not common. It's not done a lot yet, but it's coming. And other places, right now, to the idea of running 2 pair of fiber out to a monitor on a producer's desk to run an uncompressed signal out there and allotting all that bandwidth and on fiber switches to a desk monitor. We're doing that, but as compression becomes more common, the idea that maybe we give that desk monitor a low latency decompression box and we feed it a 1 or 2 gig signal. Mm-hmm. Or 1 gig signal, and we can do it on a copper network. It's just way cheaper, way more efficient. And when we're talking about latencies in 15 milliseconds, that's just not significant for a desktop monitor, but you can save a fortune on your switches.
Okay. Just before we come on to the subject of latency, one of the concerns I hear with compression is that we've got 2 issues. First of all, there's the potential concatenation challenges. And secondly, when we're mixing and keying compressed, do we not get artifacts that are quite visible?
Well, it depends on what you're keying about the artifacts. Right now, if you do a key on your desktop edit system, you're dealing with compressed files. If you get acceptable results, that means it's possible to get acceptable results. Now, right now, what that does is often a non-real-time process to get that result to be completely acceptable without detectable artifacts. So what you're really asking is how soon will processors get fast enough to do this in a real-time environment? It's not whether we can do it, it's when we can do it with a fast enough processor that we can do everything we need to do where we can't see it. We're already there. It's just we need the next increment.
Okay. All right. Latency. So latency is something we've always taken for granted in SDI networks because it's been so low. We've only really needed to be concerned about the propagation delay in cables. But as we move to IP, I'm hearing people are spending more and more money on core infrastructure, such as their switches, to reduce latency and keep latency as low as possible. What are your views on that?
Again, in a properly designed system, if your switches, not your network, but if your switches are non-blocking and you're using the appropriate hardware, latency isn't an issue. It's simply, everything will get from your cameras, from your other devices, to your vision mixers, to your monitors, within their auto timing ranges with no problem. Now, if you were to go out and buy, Joe Blow's X brand switch off of eBay, no guarantees. But on a properly architected system, that is not a problem. Now, you can talk about compression-related latencies. And one of the reasons why SMPTE is doing a the -22 standard for compression is because we've now got compression systems that do not do the whole frame. They do basically stripes of the frame at a time and allow it to be decompressed. And again, you're talking about, if they're on the same switch, you're talking about single digits of milliseconds of latency. Again, within the timing window of most switchers. We're almost there in terms of processor speed and codecs. We may be there. I bet if if you could get into the engineering labs of a few of the manufacturers, you would find that we are there. It's just not there for distribution yet. It will be very shortly.
It's certainly very interesting to hear what Dave had to say about latency and compression. And maybe, this could be complete heresy for some, but maybe we could start to think about how we would use visually lossless compression in live production environments. I'd just like to take this opportunity to thanking you for joining me on this series of talks. And what I hope you've got from this and realized is that IP is much more than just replacing an RSDI router with an IP router. It's more than just a network. It's an entire infrastructure and an ecosystem. It's about how we spin servers up, how we spin them down, how we maintain that flexibility, how we get the scalability out of a network, and how we build the entire infrastructure and ecosystem to the needs of the user and the needs of our broadcast applications. But I also spoken a lot about the agile mindset, and I think this is key to making IP infrastructures work effectively, reliably, efficiently. But the strange thing about the agile mindset is I think it's something broadcast engineers have been doing for a long time anyway, without necessarily realizing it. So maybe it's a lot closer to us than we really think. So thank you once again, and I hope to speak to you again in the future.